Good morning to all. Let us start the lecture 3 of the chapter Laws of Motion. Today I am going to cover in this lecture Newton's third law of motion and laws of conservation of linear momentum. So let us start with the Newton's third law of motion. To every action there is always an equal and opposite reaction. The statement means that in every interaction there is a pair of forces acting on the two interacting objects. The size of the forces on the first object equals the size of the force on the second object. The direction of the force on the first object is opposite to the direction of the force on the second object. Forces always comes in pair, equal and opposite, action reaction, force pairs. FAB is equal to minus FBA. Now here the following points are required to be noted, that the action and reaction are just forces. These forces always occurs in pairs. Action and reaction do not act on the same body. Action and reaction act on different bodies but simultaneously. There is no cause-effect relation, as it is misconception. Means we cannot say that this force is action and the other force is reaction. There is no cause-effect relation. It is a big misconception that we can not define that this force is a action and because of this action the other force is a reaction. The force always occurs in pairs and they act on the different bodies. Though action and reaction forces are equal in magnitude, but they do not produce equal acceleration in the two bodies of different masses on which they act. Now, example of applications of Newton's third law of motion. Now, let us tie the two spring balances like this. Now, if we pull both the spring balances with the equal forces in opposite direction, then one force is the action and another force is reaction, and here in this case both are equal to 58 grams weight. Now this is a ball. If a ball is thrown on it, that is the action, and due to reaction again it comes to the hands of a person. The gun, if we trigger, the force on the bullet is the action, force on the gun is the reaction, which is known as the recoil of a gun. Action and reaction. Balloon, rocket, action, that is the gases are coming out and the rocket is moving in the upward direction. When we walk on the ground, then weight is equal to the reaction, and when we press the ground with our foot, then action and reaction as shown in the figure. Now if we divide the reaction into the two components, then the vertical component of the reaction balances the weight of the body and the horizontal component of the reaction gives the forward motion. Now here action and reaction. When the person jumps from the boat to the shore, then because of the reaction boat moves away from the shore. Now this is the horse and the cart problem. Now here the horse is little bit looking educated. He has heard about the Newton's third law of motion. He is saying that according to Newton's law of motion, every force has equal and opposite reaction. So by the force by which I will pull the cart will also pull to me in the backward direction. Then how is it possible for me to pull the cart? So let us educate the horse, then how he will be able to pull the cart. Here it is the cart and the horse. So let us educate the horse properly. Now weight of the cart WC is acting in the downward direction. its reaction is balanced in the upward direction by RC. So reaction RC on the cart offered by the ground must be equal and opposite to the weight of the cart WC. Now, THC and TCH. Reaction pull of the cart on the horse TCH must be equal and opposite to the forward pull of the cart of the horse on the cart, that is THC. If the horse pushes the ground in a slanting manner, that is the action, as we do when we are walking. So if the horse pushes the ground in a slanting manner, the reaction offered by the ground is resolved into vertical and horizontal components like this as shown in the figure. Then the vertical component must be equal and opposite to weight of the horse WH. And if the horizontal component is greater than the friction, then the horse cart system will move forward with acceleration. Now let us understand the law of conservation of momentum. The total momentum of an isolated system of an interchanging particle is conserved. Or we can say that when two or more bodies act upon one another, their total momentum remains constant provided no external force are acting on them. As shown in the figure, when the striker is hit by our finger, then the counter goes the forward direction. Now here the car is hit by another car. Suppose a big car and a small car moves in the same direction with different velocities. Let the mass of the bigger car be m1 and the initial velocity is u1. Let the mass of the smaller car is m2 and its initial velocity is u2, such that u2 is less than u1. Suppose both the cars collide for a short time t. Due to the collision, the velocities will change. Let the velocities after the collision be v1 and v2 respectively. So let bigger car is denoted by the suffix 1 and the smaller car with suffix 2. So bigger car m1 mass, initial velocity u1, smaller car m2, initial velocity u2, such that u2 is less than u1. They collide for a short time and the velocity changes for the bigger car v1 and the smaller car v2. Now suppose that during collision the bigger car exert a force F21 on the smaller car, and in turn the smaller car exert a force F12 on the bigger one. When the force F21 acts on the smaller car, its velocity changes from u2 to v2. So therefore we can say that F21 is, because according to the second law, force is equal to mass into acceleration. So we can say F21 is equal to m2a2, and also a2 is rate of change of velocity. So we can say v2 minus u2 upon t. When the force F12 acts on the bigger car, the velocity changes from u1 to v1. So in that case F12 is equal to m1a1, and in place of a1 we can write v1 minus u1 upon t. Now according to Newton's third law, F21 is equal to minus F12. So let us put the values of F12 and F21 here, cancelling the t from both the sides. Rearranging the terms, we will get m1 v1 plus m2 v2 is equal to m1 u1 plus m2 u2. So initial momentum of the bigger car is m1 u1. Initial momentum of the smaller car is m2 u2. Final momentum of the bigger car is m1 v1. Final momentum of the smaller car is m2 v2. So from here we can say that total momentum after the collision is equal to total momentum before the collision. Now in vector treatment, let us see that the two balls. The first ball is mass ma moving with velocity va. The second ball mb moving with velocity vb. They interact for a shorter time t, and the force exerted by first ball to the second ball is fba, and from by the second ball to the first ball is FAB, and due to which the first ball starts moving with velocity VA dash and the second ball starts moving with velocity VB dash. Then consider two bodies A and B of mass MA and B moving with velocities VA and VB respectively. Their initial momentum are PA and PB, and let the bodies collide, get apart and move with final momenta PA dash and PB dash respectively. Then by Newton's second law, force into short time is equal to change in momentum. FAB del T is equal to PA dash minus PA. The change in momentum, final momentum of A minus initial momentum of A. Similarly, FBA del T is equal to PB dash minus PB, where del T is the common interval of time for which the bodies are in contact. So, and according to Newton's third law, FAB is equal to minus FBA. So putting the values from the above equations, we will get the relation P dash PA dash minus PA is equal to minus of PB dash minus PB, and rearranging the terms, we will get the relation PA dash plus PB dash is equal to PA plus PB. That is, the final momentum is equal to the initial momentum. So we can say that the total final momentum of the isolated system equals to its total initial momentum. Or we can say that if an isolated system, if no external force is acting on any system, then the total initial momentum and the total final momentum remains conserved. This is true for elastic as well as inelastic collision. Now, equilibrium of a particle. Equilibrium of a particle refers to the situation when the net external force on the particle is zero. Equilibrium of a particle requires not only translational equilibrium, zero net external force, but also rotational equilibrium, zero net external torque. Translational equilibrium means when no external force is acting, then it will remain in the translational equilibrium, and rotational equilibrium means the zero net external torque, because torque is responsible for the rotational motion. According to Newton's law, this means that the particle is either at rest or in uniform motion. Means the particle is in equilibrium, means if the total force acting on the system particle is zero, in that case the particle will remain either in motion or in a state of rest. So F1 and F2, two forces F1 and F2 act on a particle. Equilibrium requires that F1 should be equal to F2 and opposite also. So if the two forces must be equal and opposite, or F1 plus F2 is equal to 0. So equilibrium under three concurrent forces F1, F2 and F3 requires that the vector sum of them is 0. So vector F1 plus F2 plus F3 is equal to 0. Let us see through the figure that three forces are acting. Then we can say the resultant of the two forces F1 and F2 obtained by parallelogram law of forces must be equal and opposite to the third force F3. Or by triangular law of vectors, the three sides of the triangles with arrow taken in the same order represents the equilibrium of the forces. So particle is in equilibrium under the action of the forces F1, F2, F3 or F2, Fn if they can be represented by the sides of a closed n-sided polygon with arrows directed in the same sense, like this. So F1 plus F2 plus F3 is equal to 0 implies that the sum of x component is 0, sum of y component is 0, sum of z component is 0. So where x, y, z are the components of f along x, y, z directions, and these are the components of F2 along XYZ direction and components of F3 along XYZ direction. So all the x component, the sum of all x components of all the three forces equal to 0, sum of y component is 0 and sum of z component is equal to 0 respectively. So that is all. Thank you and have a nice day.